Good evening, everybody. Nice to see everyone here again tonight. This is the final night of presentations in our Climate Conversation series. Tonight's talks are falling under the heading of what can you do on your own property to reduce your carbon emissions and enhance your climate resilience. For those, I see a lot of familiar faces. Most of you, I think, have probably been here for one of our other presentations. It's great to have you back. It's great to see so much interest in this topic. For those of you who are new, this programming is called Climate Conversations, and it involves a few different elements. One is a 4-part lecture series. Tonight is the 4th of those. We also have a community-driven photo exhibit, as you saw coming up into this room. And there's also a book display a little further into the library near the fiction section with books all related to climate change, and a reading list there that you can take with you, or you can go to the Climate Conversations website to access more materials about how to educate yourself. So as I said, this is a community-driven project. A lot of people came together to come up with the idea for this series and to promote it, and to come and hear what people have to say. And this is just really the beginning. We're hoping to have more climate conversations, programmings, actions, events in the future, get people more involved and start to make a difference. So if you haven't yet, you can sign up at the back table there to sign up for our mailing list to hear about what's going on next. Let's see. You'll notice that there was a couple of cameras here filming. The last 2 presentations have also been filmed, and they're now available to view up on our YouTube page. You can there's a link to that right on our homepage about the information about this series. You should be able to link to it right from there. We're going to try to promote that a little bit more too going forward. So this will also be up shortly within a few days. This programming has been supported by the Friends of the North Kingstown Free Library. They're a wonderful organization that has done a lot for this program. We really couldn't have done it without them. And like so many other programs at the library, they are a lifeline for us and offering all the great things we can offer. So we thank them, and we encourage anybody to join that organization and get involved and help support the library in that way. So tonight we have a couple of different presenters. We were actually thrown a bit of a curveball tonight as 2 of our presenters, Ryan Kopp and Rebecca Reeves, are ill, and they are from the Stormwater Innovation Center. But we have one of the people who's really involved in this program is able to fill in with some of the materials. She's worked closely with them. Her name is Meg Kerr. Meg is a water quality scientist, environmental policy expert, who retired from the Audubon Society 3 years ago, and she was one of the founders of the Stormwater Innovation Center, where Ryan and Rebecca worked. So she's going to be able to present their materials, and we're really fortunate to have her tonight as a backup. Before Meg speaks, we also have David Caldwell here to speak. So David's going to speak first, and I'm going to introduce him in just a second. David will speak, and then Meg will speak, and then at the end we'll have a time for question and answer. So please just hold all your questions at that time. So David Caldwell Jr. is president of Caldwell and Johnson Custom Home Builders and Remodelers. Caldwell and Johnson has completed over 500 custom residential new construction and major remodeling projects in Rhode Island, and is a nationally recognized leader in energy-efficient residential construction by the U.S. Department of Energy. Dave was a commissioned officer in the U.S. Marine Corps from 1998 to 2006 and is a veteran of the Iraq War. Dave serves on numerous boards and commissions, including president of the board of the Audubon Society of Rhode Island and past president of the Rhode Island Builders Association. Please welcome Dave Caldwell.
Thank you. I am not Stephen Porter, who put this presentation together, but I was the contractor for this house. Our daughters were classmates in school, so we nerded out about this one, and we both learned quite a bit in the process of what we're going to talk about tonight. So this is Stephen's house at 61 Lorraine Ave on the east side of Providence. It's about 100 years old, and there's a lot of lessons here as we talk about what you can do at your house with a little bit of thoughtful planning to significantly reduce or eliminate your carbon footprint on the house, and some thoughts about how we do this. This is a slide here that Stephen likes to use that shows the world warming over time. This was we tell everybody you can see in real time how fast things got really warm here in recent times. So I promised them I would use this. And it's very effective for some folks that don't really understand how fast the earth is warming, because we are warming it by what we're burning, okay? So that's kind of, let me just try to move forward here. Come on, there you go. So small changes can make big changes, in other words. And that's why we're getting back to the local level here. We all know the major cause of climate change is what we're burning. Rhode Island emits about 11 million metric tons a year, and that's how much that is. So we're going to fast forward through these because this is about a 40-minute presentation I'm shortening. That's where your emissions are coming from. All right, go. All right, how do we electrify our homes? Some of this involves converting BTUs to kilowatt hours. Most houses traditionally were heated by gas or oil. Okay. We're heating space and we're heating water. Water heating is a surprising amount of energy you can use to keep your hot water. Most people here probably have a 40 to 80 gallon tank in their basement that's keeping water warm all the time. Most of us don't turn it down when we're leaving the house for a while. Okay. This is breaking down some stats on how we're using that. So this is the house at 61 Lorraine and what it looked like before we started. Okay, so 1920, wood cedar shingles, oil-fired burner in the basement, belching out that big chimney. Okay, and has anybody here ever done a heat mapper at the house with a thermal imaging camera? Okay, so if it's cold outside and it's warm inside, and you can actually use an app on your phone today to do this, but 10 years ago we didn't have that. You're watching right there all the heat leaving the house when it's cold outside and heated inside to 60 some degrees. So you're watching the air just get sucked out. Remember, that air moves from hot to cold, and the hotter it is inside, the colder it is outside, the faster that's gonna move. So that's the number one thing that we start talking about. Step one, get your insulation dialed up as best you can, okay? That's the first thing you wanna do, insulation, weatherization. It's not very sexy, but it is the most important. Get that load down. So you go up in that attic and see, how do we make sure that we're doing the right thing here? You might have seen a thing we use, it's called a blower door test. They depressurize the house with a computer at 50 pascals of pressure to see how much leakage is occurring. Okay? So that's Stephen's attic. So when it was gutted, it had very little insulation. Now it has spray foam up there. You probably hear most of that heat likes to go up. So you want to tackle that attic first. Usually it's the easiest thing to do because that's usually unfinished space. You look at your attic, look at your penetrations, look at your ceiling. A lot of people have that little attic hatch. Okay? They think they got all that pink stuff up there, but then they got a 1/2-inch piece of plywood with no insulation on it, and that air is just moving right up through there, and path of least resistance. So please look at your insulation and your air sealing and start in your attic. Okay? This is typical for a lot of older homes before plywood. You're going to see the sheathing. Okay? You're going to see how it touches the masonry. All right? What we did with Stephen's home is instead of, we replaced the shingles, we put down some polyisocyanurate insulation behind that. So you can try blowing in insulation, but that causes a lot of gaps historically, and nobody can see that. On this house, instead of repainting and fixing the shingles, we just took them all off. Okay? And put some of that Energy Star shield on it. That's R10, 1.5 inch polyisocyanurate. That gets it beyond the dew point, okay? So if you're ever thinking of re-siding your house, put some insulation behind it, okay? All right, next step, get rid of that oil belching furnace in the basement, now that you've got your heat load down, okay, let's figure out how to get, and by the way, we insulated the basement too. Let's figure out how to get those heat pumps in there so you're not burning any oil. So he got rid of the oil completely, went all electric. Mitsubishi heat pumps, okay? Got rid of the radiators and the Bosch heat pump. You can see one in the corner of the room. That's the most common convention. They call it a mini split for a wall, but now they come on the ground, they come in cassettes. You can hide them a lot more. These are for a non-ducted system. This house had steam heat on radiators with no ductwork. Now, an upside to this is he's now added air conditioning to the building, which is from a real estate perspective, that added value to the home. Air conditioning is no longer becoming a luxury item. 20 years ago, people, I don't really want to pay for air conditioning. Nobody builds houses without air conditioning in this climate anymore. That's not even thought about, for health reasons, and it's getting hotter here. So that's what's heating the house now. Just a brief, heat pumps are not new. You've had a heat pump your whole life. It's called a refrigerator. It's sitting there in the kitchen. It's usually where the cat wants to lay in the winter at the bottom, where it's nice and warm. At least my cats do. So how do heat pumps work? Very simply, you're moving heat, not making it. So that outdoor unit, which used to be around here doing air conditioning in the summer, can simply flip to doing heat in the winter. This isn't a heat pump lecture, but basically they're moving heat and not making heat is the way I like to describe it. We'll keep going. Water heating. That is a heat pump water heater right there for the basement. Those actually also can help dehumidify your basement. So if you have kind of a damp basement, that little fan in there that's using heat to make hot water, now it won't make hot water as fast as your gas hot water heater. So normally if you might only have a 40-gallon gas water heater, the recovery is pretty high. This is an 80-gallon electric. It also has the benefit of providing dehumidification in the basement. So that can be very effective for a lot of houses in the summer around here. You can pipe it out. For those who like to cook, like my wife likes to cook, we had gas stoves until we got an induction stove. Highly recommend it. Takes a little getting used to, but once you have an induction stove, you're never going back to a gas stove. All right. So that's the finished product right there. Hold on, you're going to see the old versus the new. And what's not shown here, I don't think on the slides, is the solar on the back. We're going to get to that at the very end and keep things moving along. What did I just do? Something. All right. So that's the old versus the new. Okay. The important consideration here that most people sometimes miss out on, the time to plan for these upgrades is in conjunction with either major maintenance additions or other type of work you're doing. So the marginal cost can be little to nothing at that time. The time to not think about converting to heat pumps is when your boiler breaks in February. Because there's a little bit of lag to it. There's more than just take the boiler out, put the new boiler in. So unfortunately, and this is not just residential, it's commercial and municipalities. Nobody wants to talk much about their furnace until it breaks. And then what's the cheapest way to fix it? So as a slight aside, for the Audubon Society, we spent a couple of years studying our largest property in Bristol, which is an aquarium. The gas systems were 25 years old and getting to the end of their lives, so we spent time planning how to convert those to electric. That is happening as we speak. So the marginal cost to do that was very low at the time the system needed to be replaced anyway. That's the key metric when some people use some dollar figures are out of whack. You want to plan for it a little bit ahead of time. Okay. All right, so we'll get you some metrics. All right. So a couple things that Steven's getting on here between the existing, I'm just going to hit these all on here so you can see them all. So we start with the before and after here. Because when we started this process, Stephen had a vision of what he wanted to obtain and do. And that cost about, let's say, X. And his budget was 30% of X. So perfect cost X. Really, really good was 30% of X. That's an important thing to remember too, is because some of the numbers here can look really big, but sometimes you just got to say good enough is good enough. I stopped burning oil, and I got my house down 3 times more energy efficient on the air changes. I didn't replace the windows because the budget didn't allow for it because they had fairly inexpensive replacement windows. We upped the wall insulation, the cavity insulation, got rid of the oil furnace that was steam, went to heat pumps, and you're going to see his heating bill was cut in half, and his carbon emissions went down by 70%. Okay, he factored it all the way down to the carbon you have to burn to make the heat pump work, because we have to get that electricity from somewhere right now. Okay? So half the operating expense and a quarter of the emissions. Other benefits, we have added air conditioning. These are important considerations because we are doing this for both environmental considerations, but we live in a world of economic reality. We can't get to perfect. So we got to balance all these things. Okay? What happened there? There you go. There you go. All right. Can you afford a net zero home? So these are what you're discussing when some of these numbers start to get really big. The answer is yes, if you plan for it. Or if you build a new house right now, it costs nothing extra. It's no more money to go electric than to build a conventional 2,000-foot house. In fact, it's actually a little bit less. Okay? We're down to the nitty-gritty on that. Okay? Rhode Island was the first state in the country to pass the 2024 International Energy Conservation Code with the electric readiness provisions. That was vetted to the point we were down to the nickels and dimes to show people how that cost is at very best par, or at the very least par, I should say. Okay? So we are there. Okay? The mindset isn't quite there yet. Okay? So that's what's catching up right now. Okay? All right. I skipped ahead in my head. So new construction, the price is about the same, a little bit less in some cases, but this is the way we're building our new houses almost exclusively now, unless somebody says, no, I have to have gas. Okay? Some people want the gas fireplace. You know, that's the world we live in. Heat pumps are now outselling furnaces in America. Okay? That's just the way because they're efficient, they work, they provide air conditioning. This is the way it's all going, and we're behind most of the world here, by the way, and then in Europe and Asia, and using these things for years. Okay. So what we'd like to see is anybody who builds a new building, and we've done this at the commercial scale, not just residential, go all electric or no emissions as your baseline. I cannot stress enough that you plan for that from the first time you start designing it to make it work. You have to say, we're going to do a project, we're going to renovate our home, we're going to build a building or do a major renovation. I'm going to tell my design team, my contractor, I don't want any gas or oil in the building. This is what my children did at their school. We built a new nursery school and preschool. And we started out by saying, this will not have any emissions. Okay? And it will be done at the same price. Okay? At first they said no, and then eventually they said yes. Now, I had to hit them with a shovel a few times, but I'm pretty good at that. Okay? But it can be done. You got to open some eyes. You just have to insist that it's going to get done. For an older home, the costs are higher. You're working with existing systems. That's why we're discussing doing things incrementally. Okay? Or at the, Okay? Okay? So if you have air conditioning in your house now, and it's an old system and you have ductwork, that's the easiest thing to transition to a Carrier Infinity or a Trane heat pump outside. It looks just like your air conditioner, it's just a little bit bigger. So if you have an air conditioning system, and when that reaches its point of obsolescence, put in a heat pump instead. You have all the equipment, that's going to cost you almost nothing. You just have to make sure you got enough electrical load. What we like to do is in the ductwork, your backup heat, you put some resistance heat. Some of these things may require you to upgrade your electrical service. You know, you might have a 100 amp service. Remember, you're changing your heat, your utility load of your house is now commonly BTUs and kilowatt hours, gas and electric. You're taking from the BTUs and bringing them to kilowatt hours. That may require an upgrade of your electric service. So remember that point. And if you have an electric car, you know, so your load on your house is going to electric. You know, you're finding, and we're going to talk about some duplexes that we're converting right now. We just finished doing this week. Once you actually calc the electric load of a 2-bedroom apartment, okay, that right now has gas heat, gas hot water, gas dryer, gas stove. If you take that entire apartment, and we're talking 864 square feet with a 2-ton Mitsubishi system, cut the gas meter, throw it away, you actually can spike the load on that thing to 140, 160 amps. So 100 amp service was perfectly fine. But now, if you come home at night and it's cold and you plug your car in, do a load of laundry, take a shower, cook on the stove, and turn the heat up, you're using a lot of electricity. Okay? So just on the side, remember that piece. But getting back to your older house, transition, okay, incrementally, find when the opportunities are most effective. Okay? Number one is insulation. Every chance you get, that's the best dollar you can spend is insulation and weatherization. Okay? And the line at the bottom is don't let the perfect be the enemy of the good. Okay? The perfect, you hit the point of the diminishing marginal returns curve pretty fast. Okay? So you want to stay on that fat part. Okay? And don't over-insulate. You can waste money over-insulating, especially in climate zone 5A, which is what we are in right now. Okay? There's a number of incentives out there. They change all the time. Clean heat, heat loans. OER has some good heat pump incentives right now. Unfortunately, they are only for oil and propane, not for natural gas. I have that bothers me quite a bit, but it is what it is. I know I'm running out of time here. I want to be sensitive to that. And let's see. This is a little bit about the path to get to zero and how we can all help with that. But be thoughtful about how you do it, and be proactive in thinking about when and how to do it. Don't wait for that minute to say, geez, I waited till February and I just replaced my oil boiler. If I would have thought about that a little ahead of time, I could have done something a little different. All right. These are just some extra slides. Okay? But what I'm talking about is how you can, at home, start to reduce your carbon footprint. These are the things you can do. Think about getting an electric car. We went to one of Stephen's talks a year ago. We were waiting to get an electric car, and Stephen told my wife, no, now's the time. So we bought a new Ford Mustang like the next day. So every time I see that, which is a lot of fun to drive, by the way, but go home at night and plug it in. So electric cars, how are you thinking about how you live your life? But you have to think about that. Audubon spent about 2 years getting ready to go to our net zero by 2030 and true zero by 2040 campaign. We did analysis of all our properties. We looked at what was nearing its point of maintenance or end of life cycle and what the marginal cost would be to get rid. And there is some cost to that, but we also feel it's our mission to lead on that front. So we didn't get too much into solar, which I love and have on my house, but many houses aren't amenable to that. You can't get the solar, the shading, the roof, this, that, and the other thing. But if we can build wind turbines and we have solar fields, if you can get or have access to electricity that's generated through renewables, you've got to have the end state user, which is going to be your car or your house, get off the gas and the oil. Okay? Lower your heat load. Think about how I can get rid of the things that burn things in my house. Convert it to electric. And you're then not burning, you're lowering the carbon emissions as we're all trying to turn the thermostat back here over the course of this century, okay, which is doable. It's remarkably more doable than you think. The technology is changing fast. You're going to have batteries and distributed storage are coming online right now pretty quickly. So that's my 20 minutes right about there, according to me. I tried to whip through this a little quick. Normally, Stephen takes about 45 minutes on this presentation. He's a little more exciting than I am, but I do have the technical knowledge to answer any questions you might have, and I'm glad to see some folks out here tonight. I do understand that this can be a little overwhelming at times when you say, like, I'd like to do some things. What do I do? Or, boy, I just replaced my furnace. I wish somebody would have told me about that. Or, hey, I just put in new siding, nobody told me to put in some insulation. Okay? That's just not in the marketplace, and that's nobody's fault per se, but we're in Rhode Island and we do things the way that we've always been done. We have this internal rejection of anything new here in North Kingstown. I'm born here, raised here, been here a long time. Okay? All right, I think that's it. I think Meg wants to talk now, but I'll hang around to ask any questions, answer any questions, or discuss when she's done. There you go. Okay, front row.
I was thinking about putting in an on-demand hot water heater that's electric. I have solar panels, and I did the insulation. I did all of that. I'm thinking about putting that in. My house is about 50 years old. how expensive would that be? And would it be worth doing? Is it energy efficient?
Good question. Most on-demand water heaters are gas because they're going to be about 200,000 BTUs. To take that water coming up out of the ground is cold. In the middle of winter, that might only be 38 degrees, and you got to pump it up to 108. So there's a tremendous amount of heat at that point. Electric on-demand water heaters have massive electrical loads. So the ones I've seen, we've never actually installed one because they were like 200 amps. They were huge to work because nobody wants to. They want hot water. They don't want to be small. Oh, yep. I think we're getting close here. So to answer your question, the electric on-demand systems are likely going to require you to upgrade. They're expensive. And they're going to probably require you to upgrade your electrical service.
I did upgrade my electrical. It's the question, they are expensive.
They're expensive, and what a lot of people use are...
difficult to install.
No, provided you get the electrical up there, because you're just plugging in at the main where your hot water tank is now. I would ask you to probably look at a couple of... There's smaller point sources under like bathroom sinks or a kitchen sink. You might want to consider a heat pump water heater instead. A lot less money and the rebates are there. I'm not aware of any rebates for electric on-demand systems at this time. Okay? Next. Second row.
So I have a 6-zone gas furnace, and it's one of the zones that won't shut off. So I think I need a new furnace. So I'm kind of wondering,
Did
it's
you hit it
a
with a hammer?
3-story. Oh, I've
Okay,
done a lot of
okay.
things.
Is it forced hot air or hot water?
Hot water.
Okay. So that's when you should discuss what you saw today. Do you have any ductwork in the house?
No, we have some mini splits.
Okay.
Yep.
And do those provide heat or just cold?
Both.
Okay.
But
So
it's not cold out.
yeah. So you're probably going to want some more of those. Now you can abandon in place the system you have as kind of a backup and use it sparingly. We've done that in many cases. You don't have to tear it out. You just leave it there, if it's still working, gas. But it sounds to me like you're going to need to get a heat load calc on the house, and you're probably going to want more mini splits to heat the house. I think you're up now,
I'm
right?
up.
All right.
Thank you, Dave.
Okay. We'll be back.
Hold your questions.
Yeah.
I'm sure you'll probably have more questions for him than for me. So I'm Ryan Kopp and Rebecca Reeves. I'm Meg Kerr. I have been working with Ryan and Rebecca since the Stormwater Innovation Center got started. I'm not them. It won't be as good as their presentation, but we'll do fine. So this is a presentation on managing stormwater at home. And the slides are all Ryan and Rebecca's. So as we've heard from previous presentations, if you've been regular attendees at the Climate Conversations lectures, we know that one of the earmarks of climate change are these increasingly intense rainstorms. We don't actually have to come to the lectures to know that, just watch the rain outside your house. But this is a graph showing you how intense rain has become. And the Northeast is seeing rain intensities even worse than other parts of the country. And when we're thinking about stormwater, stormwater is the water that runs off of impervious surfaces after it rains. That's what stormwater is. So the picture on the left shows you when it rains, if the soil, if the ground that it's hitting, the rain is hitting, won't soak the rain in, it just runs off. So those are impervious surfaces, and they cause the rain to run off. Pervious surfaces like lawns, like in this picture, absorb some of the water. There's one little rogue raindrop there to the right to make the point that even lawns, you might think your lawn is a totally pervious surface, but there's runoff even from a lawn. Oftentimes your lawn is hard packed and there's quite a lot of runoff from it. We'll talk about that more. So this is a picture of a home to get us thinking about where all the runoff is occurring. So you've got your roof, you've got your driveways, you've got your roads, and the rain that hits all those impervious surfaces flows down the road, it's going downhill, into the storm drain, if you have a storm drain. Not every place in North Kingstown or anywhere has a storm drain system, but it runs off eventually to a water body. That's where the water will end up. So if it goes into the storm drain, then it ends up in a pipe somewhere discharging to the beach or to a river or stream, a local water body nearby. And if it goes into the road flows its way eventually to a water body somewhere nearby. And stormwater runoff has both water quality and water quantity implications. I have been working in water quality my whole career. I started in the 1980s. And even back then, the EPA was saying that the biggest source of water pollution was non-point source runoff, which is runoff pollution from stormwater. So we have, as a country, done a pretty good job cleaning up industrial waste and sanitary waste from our municipalities, but the runoff pollution is a big problem. And that picture on the left shows a cyanobacteria bloom in some water body. We get them all over the state. You hear those health advisories in the summertime. The Stormwater Innovation Center is centered at Roger Williams Park, and those ponds up there have cyanobacteria blooms every summer. There's also water quantity implications of runoff. This is a really a big flood showing in this picture. I don't know about you, but I've been somewhat riveted by stories from western North Carolina and the flooding that happened there. Of course, that was a hurricane, but all that flooding, that's all runoff that caused those rivers to rise and all that flooding to occur. So even when the rain isn't a hurricane, you still have water quantity, you have flooding, you have the rising of your streams from runoff from our impervious surfaces. So this is a map showing North Kingstown. You see Wickford Harbor right there, Fishing Cove, and the Wickford Harbor area, and everything in red is impervious. So you can see Quonset. Quonset is like paved, and it's all impervious. You can see the high school. You can see where there's commercial development. So impervious cover can be commercially owned, it can be governmentally owned, it could be residential as well. So you look at all these little neighborhoods with little roads going in, and all those little houses with their roofs show up as impervious cover. When it comes to some of the larger sources of runoff pollution, the town of North Kingstown is mandated, they have a permit to manage their stormwater pollution. We have a part-time staff person here in North Kingstown, Joel Roca, who's a stormwater specialist in town, and he works with all the commercial, primarily the commercial entities and the subdivisions that have stormwater permits. But you can see from this map that all of us, where we live, have impervious cover and contribute to the runoff pollution. So why do we care about runoff from our homes? As Dr. Chase said during his lecture, if you were here for that one, what we put on our yard chemicals, fertilizers, pesticides, when it rains, runs off, and it goes into the storm drain, into the local water body. So we all bear some responsibility for keeping the runoff from our homes as clean as possible. This is obviously not a picture of somebody's home, but makes the point. So what do we do to make our home better reduce the runoff from our home? And this is a really interesting, I think, two slides. So the first thing to do is to do as much as we can to replace impervious cover with pervious cover. And so this picture and the next picture shows the same home. Look at the solar on the roof, look at the design of the house. And these people went all into turning their lawn into sort of a wild habitat area in front of their house. Ryan wanted me to point out that not everybody's house looks like this. It's not going to look this beautiful all the time. My husband and I have a yard that sort of looks like this, and we've got some of our neighbors here. So it doesn't always look this beautiful, but it does sometimes. And it is awesome habitat for pollinators and for birds. So if you can go in for really transforming your yard, go for it. But you can do bits and pieces of this as well. There's other small steps you can take, like replacing some of your impervious cover, your walkways, your driveway, with making it permeable. So you still have a paved surface, but you're using a permeable surface. So this is a photograph of pavers where the water goes into the cracks between the pavers. There's also asphalt, permeable asphalt that can be installed. There's ways to make your paved areas permeable. As an aside, it does require, if you want to keep it permeable, keep your pavers permeable or the asphalt permeable over time, it does require maintenance. You have to keep cleaning these to keep the water running through them. You can also plant trees. Trees are an amazing way to absorb water in your yard. A large, established tree will remove 1,000 gallons of stormwater per year. And the picture on the left is from Providence. Providence has a really big effort underway to plant trees all around the city, recognizing the stormwater benefits that they provide and the heat benefits that they provide. You get trees, and a treed neighborhood is a lot cooler than a neighborhood without trees, and you can see it on heat maps. So getting trees into our neighborhoods, getting trees into yards does a lot for a lot of environmental issues, including stormwater. Other things to think about are just good housekeeping measures in your yard. So the types of things that run off are pet waste, chemical disposal. I have seen people actually discharge, empty oil into the storm drain. I think the education that has happened around the state, around the country, around storm drains drain to the bay, those little stickers that go on a lot of these storm drains, has helped people think about it. I think people used to think of this as great, this is just a garbage place, I'll put my garbage here. But it still happens. So you don't want to wash your car in your driveway where it's going to run off and go down the storm drain. You're just putting soap into whatever the closest water body is. You want to cover your trash so it doesn't ooze, gook onto the pavement and into the water body as well. I think we've done a good job educating people to pick up the waste after their pets. But I don't know how often you all have seen the little plastic bags sitting by the side of the road, still full of poop. And if you go down Rome Point and walk down there, there's poop bags everywhere. So we got a long way to go. It's not just getting the poop into a bag, it's getting that bag with the poop into the garbage and not just sitting on the side of the road, because actually the poop in the plastic is worse than probably the poop just sitting there by itself. Another way to manage some of the runoff from your home is through installing rain barrels or cisterns. This photograph shows an above-ground cistern, but there's also below-ground cisterns. I asked Ryan if he knew of any cisterns installed in this area. He didn't know of any. Maybe some of you do. But I do know of a lot of people that have rain barrels, and it manages not a huge amount of the water coming off your house, but it does make a difference. One thing to keep in mind, if you're taking the water off your roof, it is removing pollutants from your roof and putting it in your rain barrel, so it's non-potable water primarily that you're going to have in your rain barrel. And I'm not sure what they do about treating water in a cistern if it's mostly coming off the roof. But that is something to keep in mind. So we've got some slides here about how to retrofit your home and install a rain barrel. This is the equipment that you will receive if you get a rain barrel retrofit kit. And the first step is to drill a hole in the downspout that you want to put the rain barrel in. Then there's a little connector, and this little gadget will once the rain barrel is full, the water will get diverted back into the downspout. So the rain barrel won't sit there overflowing if you have a large rain. It'll just fill up the rain barrel. Then you connect that to the rain barrel, and the rain barrel has 2 exit points. The lower one is for cleaning it out, and the upper one is where you withdraw the water when you're using it for watering your lawn or your garden, mostly for non-edible plants. And usually you can buy a rain barrel. It comes with instructions, and it's not that difficult to do. Does anybody who has rain barrels installed at their homes? Look at that. So if you got questions, ask these people. They've already done it. That's great. This is a photograph of an intern that worked at Audubon with Ryan and Rebecca. She was an art student at a local high school, and she worked to decorate and put paintings on the various rain barrels that Audubon then auctioned off. But they don't have to be an ugly barrel sitting in your yard. It can be very pretty. Just find yourself an artist or do the art yourself. So that's one way to manage the water. The next one is rain gardens. A rain garden is an area of the yard that is designed to handle a certain amount of the runoff from your roof. And you direct the water to the rain garden from one of the downspouts coming off your roof. So the first step is to look at your house and figure out where the downspouts are and where are they going. The one on the left is directing the runoff from the roof onto the driveway. And from the driveway, it goes down the road into the storm drain and into the nearest water body. So a simple thing you could do there, whether you want to put in a rain barrel or not, or a rain garden, either one, is just redirect that downspout back onto the lawn or away from the house and towards a more permeable area. And at least that way some of the water will get absorbed into the yard. So take a look at where the downspouts are and see whether there's a place in your yard that's a good spot for a rain garden. It should be about 10 feet away from the house. You don't want to redirect all your stormwater into your neighbor's basement. You know, we've heard things about that too. You should be handling it on your own property and helping it to absorb. Gotta look at my notes. Oh, and not all yards work. Sometimes yards are too small, sometimes you don't really have good area for it, or there isn't a good permeable area. But it's worth taking a look if you're interested in doing it. The third thing to do is to test your soil. You've got to see how permeable the soil is. If you know about soil maps, if your house is built in an area that has type A or B well-drained soils, you're in good shape. If you don't know what type of soil you've got, you can dig a hole about a foot deep, fill it with water, and let it drain overnight. And then the next morning, fill it back up again. You want the soil to be saturated when you do the test. And then see how long it takes for that second puddle of water to drain. If it drains within 24 hours, you've got well-drained enough soils to put in a rain garden. You then want to size your rain garden to handle the runoff from your roof. Although this is, if you're going to put the perfect rain garden in, it should be sized for your roof. But something is better than nothing. So if you can't do a rain garden big enough to handle the calculations that we're going to run through here, it's still worth doing. It'll just overflow and go in other places in your yard just like it does right now. So you want to measure your roof area, the length versus the width. Notice whether there's one or two downspouts coming off of that area of your roof. You need to think about how much rain, how big a storm you want to handle. It's recommended you want a 1 to 3 inch storm. That's not a humongous storm, but a good sized storm. And of course, it depends on the available space. And then you want to calculate the volume that will come off your roof. So the length versus the width versus the depth of the water gives you the number that is the volume of water that you want to infiltrate in your yard. Then you dig a garden hole big enough to match that volume. And use your best estimate to come up with that. Ryan pointed out that in this drawing, the person who dug this garden has a berm around the outside edge there that gives it more volume than if you just dug it level with the ground. You also want to think about the tilt of your yard. You don't want your rain garden then draining back into your house so that you're taking the water off your roof and then putting it back into your basement. You want the garden to be draining away from your house. So just things to think about. If you don't know, we work with a guy up at Roger Williams Park. He's the Deputy Director of Parks for the City of Providence, Brian Burns. Water is easy. Go out when it's raining and wander around your yard and see where the water's flowing. That will tell you which way your yard tilts and where the rain goes. It's really quite easy to do. You know, it may be very subtle because it might look totally flat, but the rain's flowing one way or another. So you can get a sense for your yard by just going out when it rains and see how it goes. There are tools on the web to help you do these calculations if you want some help. So this nifty little calculator came from raingardenalliance.org /right/calculator. It'll do basically the same calculation that we just went over if you want to figure out the size of your rain garden. It also has information on how much it would cost and how to size it. Once you've dug part of the whole getting your rain garden to work is you need to get the water from your downspout to your rain garden. So you need to extend the downspout with some piping to get it to your rain garden. And probably bury that, put it deep enough so you can bury it afterwards. And then plant the garden with native plants. And you'll end up with a great pollinator area. It probably will beautify your yard, and it'll also infiltrate some of the stormwater coming off the roof of your house. Ryan put in a rain garden at his house, and he didn't go out and buy plants. He found a seed mix, a wildflower seed mix, and he spread it around, and his actually looks quite beautiful. So it doesn't have to be too complicated. And the web is full of tools for putting in rain gardens, and there are 2 QR codes. The first one on this is from the Stormwater Innovation Center website, and it's about managing stormwater at home. There's many of the tips that I've been through here. And the second QR code is a rain garden guide that I think EPA or DEM put together. And when these slides are posted on our site and on the library site, you can check out those QR codes. And that's it. Thank you. Come answer some more questions. We're open for questions for both of us, but there were a lot of hands for you, so come on up. Actually, yeah. I can put the QR codes, but I don't know if they can take it. I'll try. Go ahead.
All right. Who's got a question for Meg? There you go.
So we replaced our furnace a year or so ago, and our air conditioning units are up next. We have duct heat left the house, duct cooling left the house. Can a heat pump work concurrently with a oil furnace?
Concurrently isn't quite the right word, but they can coexist together, yes. In other words, you can abandon the furnace. It can just sit there because it still works. Don't do anything with it, just leave it alone. Consider it your backup heat. And then just put in the heat pump. When you use your air handler, you're all set. Yours is very easy to do. So when it's time to replace your air conditioner, put in the heat pump. You can still have your oil furnace, just don't use it. It's sitting there in case of emergency, if you will. That's a pretty easy answer. Okay.
If you put in an all-electric house, we have storms from time to time that result in power loss, sometimes for days at a time. You can get yourself a Generac, but then you're talking about burning propane.
So yes, but what you're going to be able to have shortly are affordable batteries. Those are coming quick. They're going to be maybe the size of this lectern that you put in your basement, like the size of 2 bar fridges. Those are coming fairly quickly. The Tesla batteries are expensive, but in the short run, you could either get yourself a little Kohler generator, fill it with gas, and, fire the house up, or you would have, in the case of going all electric for public buildings, there's still a carve out, if you will, for fire life safety systems that would need an emergency generator. Right now it's propane, but before you know it, those are going to be batteries. Okay. All right. Anybody else? Diane?
When you were talking about like planning and doing for the transition,
For example, in my son's house, I think they're heating with propane for the whole house. And how do you start planning for the transition? I mean, what are the steps you take?
First, you have to make the decision, here's what we're gonna do. Okay, what type of, does he have hot water or ducted system? That gets back, if it's ducted like regular air conditioning, if he has air conditioning, when you replace the air conditioning, just put a heat pump in. Then it'll do heat and air conditioning, that's easy. But if he has hot water baseboard or steam, I'm assuming he does not have central air conditioning right now. We consider the Mitsubishi systems to be central air. So you can get the condenser, the outside piece, and you can do one at a time. It's not all that difficult to do, or you could start putting that in or just say, hey, we're gonna put in central air conditioning with the Mitsubishi Fujitsu carrier. That'll provide you heat as well. So that, it is an expense, but you'll get a return on it if you have forced hot water baseboard heat or steam and now have, quote, central air. That adds economic value to the asset if you own it. Sometimes, or frequently, it'll almost offset the entire cost and value added to the asset, putting your real estate agent hat on. So that would be considered a good investment to have central air in your home rather than the window units, you know, that are also much less efficient. Any questions on rain gardens?
Okay.
Yes?
Not on rain gardens. Can you explain the difference, what an air source versus ground source heat pump means?
Good question. So air source heat pump is what your refrigerator is. So you're moving heat through air. A ground source heat pump is actually more efficient. Many people call that geothermal. That's technically the wrong word. Geothermal would be like the hot springs you would see out in the desert, but anyway, or Iceland. What you're pulling with, you know, ground source heat pump is a well. You're gonna have to drill 2 wells. You're gonna be pulling the water up. Normally, you're putting a glycol mix in there, but the water coming out of the ground is usually no less than 55 degrees when you get down below about 10 feet. So you take that and you move the heat from the water into the building. Ground source heat pumps are more efficient, they are a lot more expensive, and they tend to work the best in much larger buildings. Okay? I've not seen in my verbiage that those pencil out well at the residential level. They're expensive. They work great, and they are more maintenance. So be advised that when you're moving water with the pumps, you got to have that. If anybody has a well in the house, you have to have a 1/2 to 1 horse pump to pump the water. So you have to use energy just to get the water moving. And then you have to use electricity to pull the heat out of it and move it. Yeah. All right, anybody else? All right.
Solar question. Live in a condo, 2 units, and I haven't been able to get beyond a preliminary proposal because as soon as they hear the word condo, they go silent. So there seems to be a barrier there, and I don't understand what it is.
I can't give you a good answer to that one, but yeah, the condo thing gets people confused because I'll blame the lawyers, you know, because now it's an asset. Who owns the solar? How does that affect? But ideally, if you had a townhouse, perhaps, then you could, you know, have a blank. And but that is a challenge. I can't answer that one for you, but I hope you could have solar on it. Yeah. Rain gardens? Anybody? Be careful what you plant in a rain garden. I don't think we touched that, right? You can actually have plants that can drown in a rain garden. So that's a common thing. I like rain gardens, but you can actually drown your plants if you're not careful. DEM and CRMC both have lists online about what are hydrophobic in this climate zone.
I was thinking about getting rain barrels, but I was concerned that there might be a nursery for mosquitoes. Is that problematic? And would a rain garden actually be problematic for mosquitoes?
So I think the rain barrels come with screens to avoid the larvae and the mosquitoes from getting in, so you're protected from making that a breeding ground. And you do have to clean them and remove them at the end of the season and bring them back in the spring. So a properly installed rain barrel should not be a problem. And a properly operating rain garden ought to drain in time for it not to be a problem either.
Thank you.
All right. Oh, I see a question. Yes, Mary?
Is there a one-stop way of learning if the situation that your house is in is good for solar, what you should do before getting solar, and just a one-stop shopping place.
No, nope, doesn't exist. Okay, that was easy.
Usually a solar
okay,
company,
yeah.
you get a recommendation from people who've had solar, find a reputable solar company, and they'll come out and give you some advice. They'll look at your house.
Right.
Sometimes they tell you have to chop down trees, and you may or may not want to do that.
You can actually have an app on your phone to do some very minimal solar shading and see how your house is situated for solar. The point of my story is before you get to the solar, I would ask that you consider some of the other things. Lowering your heat load or your utility load, insulation, weatherization, and then changing your load to electric versus BTU fossil fuels.
Yeah,
That's what I would like to see. A lot of people like to jump to solar. I understand that. I grew up in a solar house. My dad built solar houses in the 70s, back when it was a little different. But the takeaway from tonight is, as you plan for it, think first, reduce my energy load, insulation, weatherization, then change my BTUs that burn to kilowatt hours that don't. And if we can get to the solar after that, that is wonderful. But
well, and there's a very practical reason for that, because you're allowed to size your solar, you get support for sizing your solar based on how much energy you use. So how much electricity you use, sorry, yes. So if you're going to electrify your home down the road and get well, what Bob and I did is we got solar and then we bought an electric vehicle. And that's the wrong order because we charge our vehicle at home and we now use a lot more electricity than we used to do. So you should do all the electrification you want to do first and then put in the solar to meet that need, which is basically what Dave was saying.
Thank you, first of all. Beautiful presentations. I really love the idea that you're promoting this conservation and wonderful rain garden idea. I'm just curious, is there any incentives for people to either put in rain gardens or to even not develop portions of their yard so that...
Like financial incentives?
Well, yes, or even in kind of compensation.
Not that I'm aware of. So in other parts of the country, some cities have a financial system where they have fees that are assessed to each home and each commercial parcel based on how much impervious cover they have, and the money that's raised pays for managing all that stormwater pollution. And in situations like that, there are benefits, financial benefits for having rain gardens and dealing with your impervious cover. There's nothing like that yet in place in the state of Rhode Island, and it's a long way away. Yeah.
I wasn't just thinking just the rain and runoff, but also the fact that we're talking about a full ecosystem. And so having people be aware that the kinds of things they plant, how much of their property they leave undeveloped would be important.
Yes, and you get to feel good about it. So one of the ideas that we would love, I'm going to ask questions of you a little bit. So those of us who've organized the climate conversations workshops, and there's a bunch of us here in the room, this is the grand finale, as you know, and the photos will come down on Monday. But we never intended the conversation to be short. We'd like to keep the conversation going, and we'd like to keep doing useful events and things as we move forward. So if you have ideas, if you could add your thoughts, your contact information and your thoughts, you don't have to do it, but it would be nice if you would ... Put it on that piece of paper back there. So for example, one of the things we've been kicking around is Ryan and Rebecca owe us. They weren't able to come. So when they are healthy, getting them back and maybe doing a more hands-on workshop on doing rain barrels and rain gardens, and maybe in the spring when we can get out there and do some digging and planting together. It's an idea that we've had. showcase some of the good stuff that's already around in town. Sorry, yes.
Oh, I just wanted to mention that there's $75 off on rain barrels at Wickford Lumber.
Okay.
For North Kingston residents, you just have to bring in a bill or something. So that's a little bit of an incentive.
No, that is an incentive. I didn't know about that. That's great. Yeah. Yes.
As we all change to 100% electric in our houses, we're just burdening up the power source. What are they doing about a carbon burner?
So we're talking about the utility, correct? Okay. The hope would be that we're going to have wind turbines in our backyard over here, which is, you know, the Atlantic Ocean, and some more solar fields in Rhode Island. We would fairly easily be able to hit our utility load if all of Rhode Island went all electric. We could do that fairly easily between wind turbines and solar. That's not now. The next piece is the utility, the grid, and the infrastructure. Yeah, that's going to require some attention for sure as our electricity usage goes up. These are fairly easily to achieve from an engineering perspective. And you will likely start to see battery storage both at the utility level, which look like 20-foot shipping containers, and you'll be able to have battery storage at your house and in your automobile. So that's called distributed storage. Then you'll be able to look at your utility meter, your electric meter, and take this little device here, and you'll be able to actually buy and save and sell electricity at any moment in time, or program yourself as to when you want to charge your battery, which could be, when the renewables are high. All this technology exists right now. It's bumping up against regulated utilities who have less incentive to move very fast. If you see what's going on in Germany, when the wind turbines are spinning late at night, they are, quote, dumping electricity. In some cases, you're signing up, they're paying you to take it, to store it. Okay, so right now, the frontier is storage. That's where it's at right now. We know how to generate it. We don't know how to store it properly, but that's what's coming faster than you think.
You mentioned mini splits, and at the same time, I think you mentioned there are some other ways of generating power through the new technologies, as opposed to going straight to a mini split. Am I correct? Did you say that? And what are they?
So there's different types of mini splits, but there's also some low voltage floor heat, and it's a European product out of the Netherlands. It's pretty effective. We've used some of that. High voltage electric floor heat, and let me rephrase, I used the wrong term. Direct line resistance heat is very expensive to run, but low voltage floor heat, the Europeans have us beat on a lot of these type of things. That's a great heating source, or some you can use if you want to tear your floor out. That's another thing you could put right under the floor. It's like step warm floor if you Google it. But for the most part, what you're putting in the house are the mini split wall mounted, the floor mounted, the ceiling cassettes, the ductless. They call them a ductless system, but a ductable ductless that goes like a plenum. That's the convention that we're using the most.
What are the ductless systems?
You'll see ones that both can convert into, they're ductless systems. Even the ones that you can hide in like a drop ceiling, for example, more commercially, they call that a plenum, and it just sort of goes out from that. But any reasonably decent HVAC contractor will be able to give you your options on that. They're hidebound, but they're getting more efficient in explaining these things to consumers, as opposed to just, hey, my heat broke, fix it. Okay, do what Dad always did. Now, you keep telling them they're hearing we want to do this. It's actually fairly easy to install this equipment. And you don't have to have certain licenses that revolve around oil and gas combustion and ventilation.
And is there anybody that you can ask to come and evaluate? I know, when we were considering other things, you could get the power company to come. But now, to just do what you did in this presentation, but for the individual house, and to go give you say, all right, let's start with this, and this, and help you with the timeline.
So you can start with rise, they'll come out and do a very baseline energy audit. But what you're really looking for is a home energy rater to come out and test your house. That guy, that's called a HERS rater. If you want to Google that, HERS, home energy rater. Okay, and that's when they put the blower door on the test and they test it. They actually do a test of the house, but that costs more money. Rise is generally free. Okay, those are your two starting points. But in America, that is not a common profession yet. Over in Europe, it's much more common because if you sell your house in Germany, you have to be able to document all these things. And if the threshold is too low, law requires you to pull it up. There's metrics to it. Like, it doesn't have to be brought up to current code. That's not the proper term, but they're like, man, you got to get your house more, at least up to this minimum threshold for a 100-year-old house before you sell it. I mean, we sell houses in Rhode Island right now, and if you go into the MLS and be like, okay, I have oil heat, and here's how much I use for the year, most of those you can laugh at. Like, okay, you use that much, that's because you turn the thermostat to 50 went to Florida for 3 months. Nobody knows, okay? So that's the way it works. So nobody's there to validate that.
I think we have time for one more question.
Yep. Okay. And one last thing, Meg forgot one thing on the rain gardens. Be aware where your septic system is. Okay. Don't put it on top of the septic system. Okay. Okay. Very important point.
That's a good
okay.
point. Yeah.
I thought
There's also a dig safe. I don't know if you dig deep enough to worry about that, but yeah.
Safety first, always.
All right. Well, thank you very much.